Hi everyone. So welcome to a little past paper session on statistics in maths. So we'll be doing about 3 questions today, and this would cover, if not 100%, 99% of everything you need to know in statistics, including how to draw graphs properly. Okay? So let's take this first question. 60 students took an algebra test, which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in a table below. Okay? So the correct answers range from 8 to 15. So the first question asked to determine the number of students who had exactly 13 correct answers. So this is as simple as watching a table, finding where the number 13 is, and looking across to see how many got 13 answers correct, and that would be 11 students. Okay, I'm writing 11 students here. Okay. The next question asks for the modal number of answers. So the mode is the frequency that occurs the most, okay? That has the highest frequency. So the column on the right by the number of students is also called the frequency. So we simply need to look at which number on our right hand side is the largest, and that is 14. So the number of correct answers that correspond to 14 is 9. So 9 correct answers. That's the mode. Now they want to know the median number of correct answers, and this is the one that gives students the most amount of problems. Okay, so first of all, to find the median, we know we have 60 students. Okay, so we need to find where the half of that 60 is, okay, and which student that would be. However, if we were to write out 1 to 60 in a straight line, you could not find a simple person in the middle. For example, if we were to write out 5 numbers, okay, 1, 2, 3, 4, 5, obviously we could tell that 3 is the median, that's the middle. However, if we had 6 numbers, an even number, there's no real middle. The 3 and the 4 are the middle numbers. So the median of an even number, we need to take the 3, add it to the 4, and find the average of those. Okay, so that is the median of such a number. But that's not what we have. We have 60 numbers. So instead of writing out 1 to 60 like we did 1 to 6, we can come up with a formula. So to find the median of any number, we take the number 60, we add 1 to it, and then divide by 2. If we do this, we'll get 61 on 2, which is 30.5. Okay, that's the median of the 60. However, that's not what we are finding. This is 30.5 students, and well, you can't have a 0.5 of a student, right? So we are looking for the 30th and the 31st student. We need to find how many questions they got correct. Okay, now it's a simple way to find this. These are the first 6 students. These are the next 14 students. So far we have 20 students there. Okay, they got 8 and 9, right? So 20 students got 9 or less in the question. 2 people got 10, so that's 22 in total. 6 people got 11, so we add 28, and then 2 people got 12. So here we have our 30th student. So that's 1. However, we still need to find the 31st student. And where would the 31st student be? Obviously in this one. The people who got 13, okay? So if you add 11 to 30, we'll get 41. So obviously the 31st student is in that batch, okay? So the 30th student would have gotten 12, and the 31st student would have gotten 13. So how do we find the 30.5? We simply find the average of 12 and 13. Okay, so statement wise, this is how we go. 30th student, he got 12. The 31st student, 13. And to find the median, we take the average of them, which means 12 plus 13 over 2, 12.5 is our median. A lot of work for 1 mark, I know, but it's still a mark that we got nonetheless. Okay? The next part of the question asks the probability that a student chosen at random had at least 12 correct answers. Now, this is quite simple. All we need to do is to find out how many students got 12 or more. Okay? So here we have 2 people getting 12. That's 2 so far. And I'm going to write 2 here. 11 people got 13. So far that is 13 students. Another 9 students got 14. So that's 22 in total. And then 10 students got 15. So that's 32 students in total got 12 or more. And how many total students we had? 60. So the probability of a student being chosen at random that had at least 12 correct answers would be the 32 of them over the 60 in total. And we can narrow this down. 2 can go into 32 17 times, 2 can go into 60 30 times. So the probability is 17 over 30. Okay? That's quite easy. Right. So let's move on. Look at this question now. 100 students were surveyed on the amount of money they spent on data for their cell phones during 1 week. The table below shows the results as well as the midpoint for each class interval. Just so you know, these are your classes, okay? Classes, right? And they got the midpoint by simply adding the higher number to the lower number and dividing by 2, the average, okay? Just so you know. So, using the table, determine the modal class of the amount of money spent. Again, this is quite easy. We just need to look at the highest frequency, which is the number of students. And that would be 31. And what is the class? 70 to 80. The X simply means whatever the number is, it's between 70 and 80, okay? So the modal class, we just need to write it back. There we go. Part B. Calculate an estimate of the mean amount of money spent, giving your answer correct to 2 decimal places. Now, to calculate the average of groups or classes, we needed to find the midpoint of each class as an estimate, and they did that for us. So we're very happy about that. Okay? The next part of finding the mean is that we need to find the subtotal of each midpoint. Okay? So I'm going to have to create another column in this table. So here we go. And we're going to label this subtotal. Why are we creating this? Because we need to find if 7 people spend $55 on average, then how much money is that in total? Okay, so 7. So we don't need to actually calculate if you don't want to, but you need to use the calculator at some point in time. Okay, so I like to calculate everything clearly so the examiner could see exactly what I'm doing. Okay, so I'm going to take 7 by 55, 385, and we should write our formula here. Okay, so I'm going to write f multiplied by x. F multiplied by x gives me my answers over there. The next one, 11 multiplied by 65, 715. Then we have 31 multiplied by 75, 2,325. 29 multiplied by 85, that's 2,465. And finally, 22 multiplied by 95, that's 2,090. And finally, we need to add all of these up to get our final answer. So I'm adding right now. Okay, My final answer, $7,980. But this is not the mean yet. The next thing we need to do now is to divide this number by our frequency. Okay? They said 100 students were surveyed. So simply, I now need to divide my subtotal by the total students. This is 7,980 divided by 100. And without using a calculator, we know the answer is 79.8. However, they said correct 2 decimal places. So I simply need to add a 0 over there. That will give me my 2 decimal places. Now, why would they ask for 2 decimal places? Because we are dealing with money. Okay, so money, you always need to quote your cents in 2 decimal places. Right, so your final answer is $79.80. So Damien reports that the median amount of money spent is $84. So we need to explain why this could be correct. So let's go back to our table. Right, so remember the median would be the middle of the 100 students, and guess what? 100 is an even number. Okay, so I'm just going to do it on the side here so we don't have to keep scrolling back and forth. Okay, I'll change the color to make sure you don't get confused. Okay, I'll just erase this here so you have some space. Right, so remember our median starts off by using our little formula, 100 students plus 1 over 2, and we're going to get 50.5. Therefore, we are looking to find the 50th and the 51st student. We need to know how much money they would have spent. Okay, so let's do it again. This would be the first 7 students here, spending between 50 and 60. The next 11 students to make 18 would have spent less than $70. The next 31 students would have spent less than $80. And if we add 31 to 18, we'll get 49. And here we have the next 29 students spending between $80 and $90. Now, without even needing to add 29 to 49, I know that that 50 and 51 would come right after 49. So obviously, my 50th and 51st student would be in this range. And what did Damien say the median was? 84. Does 84 lie between 80 and 90? Yes, it does. Okay? So that's really what we need to put in that answer. Okay? What I said. Alright, so I'll just give you a quick rundown. The median students are the 50th and 51st students, which lie in the 80 less than x less than equal to 90 class. Therefore, $84 can be correct. Okay, simple. Right, so let's look at part B. Here we have a table, and it gives information on the mode of transportation to school for 100 students. Okay, so we have boys, girls, and we have the modes of transportation. Either they walk, cycle, or drive. So now we need to complete the table by inserting the missing values, and this is quite easy. Okay, so there are 2 totals here. Okay, so the totals on this side, we are adding up these 3 over here to get those totals. The totals on the bottom, we are adding up this one and this one to get the total on the bottom. So if 15 boys walk and they tell us that 23 students in total walk, how many girls walk? Well, we could just take away 23 from 15 from 23, sorry, and we're going to get 8. Okay, let's see what else we can work out. 23 in total walk, 40 in total drive. and 100 students, there are 100 students, right? So what do we need to add to 23 and 40 to get 100? So 23 and 40 is 63, okay? So 100 minus 63 would be the answer that we would put for cycle, and that is 37 students in total cycle. Well, let's look at the top now. 15 students walk. We don't know how many, 15 boys walk. We don't know how many cycle. But look, we know that 37 students in total cycle now. And if 18 girls cycle, we could just take away 18 from 37 and we are going to get 19. Okay? 19 boys cycle. And the last missing box is how many girls there are. If there are 48 boys and there are 100 students in total, it means there are 52 girls. Another way of getting that, we could have added 8 plus 18 plus 26. We would get the same number, okay? And we have completed our table. A student is selected at random. What is the probability that he or she was being driven to school on that day? Now they said a student, okay? So a student could be any of the 100 students, right? Now we need to find how many were driven. So these are the drive here. 40 in total were driven. So simply to find the probability, we need to put how many were driven, 40, over the total amount of students, 100. And we can simplify this to 2 on 5, okay? That is the probability of a student being driven. The next question asked, one of the girls is selected at random. So it's not 100 anymore. There's only 52 girls. What is the probability that she did not cycle to school? So we know it's going to be out of 52 already. And how many girls cycle? 18. But we want to know how many girls did not. What is the probability of finding a girl that did not cycle? So we simply need to find the girls who walk and the girls who drive. And what does, if we add up those, we are going to get 34. So 34 girls did not cycle. So the probability is the 34 girls who did not cycle over the total amount of girls. And that is 17 on 26. That is our probability of finding a girl that did not cycle. Okay. So just one more question now, and this would involve drawing out a graph, okay? So the table below shows the time that 80 students waited to be served at the canteen, okay? So here we have the classes on the left, 1 to 5, 6 to 10, etc. We have the number of students, and then we have the cumulative frequency. So cumulative means that you are adding up, okay? So they started off with the cumulative frequency. So in the second column here, you can see they got 11 because they added 7 to 4. Okay, 7 plus 4, 11. They got 22 because they added the 11 to this 11 over here that we got before. So now we could use that pattern to fill out our table. So the next one would be 18 plus 22. That is 40. The next one, 22 plus 40, 62. 10 plus 62, 72. 5 plus 72, 77. 3 plus 77, 80. So 80 happens to be the total amount of students that were being served, and they told us that 80. So we know that our frequencies are correct now. Okay, that's a way of checking over. Now they want us to draw a cumulative frequency curve. So the axes on the graph for a cumulative frequency curve are obviously the cumulative frequency, but what do we put on the other one? We need to find the upper boundaries of our classes, okay? So a class can be further spread it out with boundaries, right? There's a lower class boundary and an upper class boundary, and we go 0.5 below and 0.5 above the class. So for example, the class boundaries of this first class 1 to 5 would be 0.5 to 5.5. This is your lower class boundary, upper class boundary. Okay, and so it will go for all the classes. In the cumulative frequency curve, we pay attention to the upper class boundaries. So the most sensible thing to do is to create another column here in our table. Alright, and we're going to label it upper class boundary. So it's the upper class boundary of 1 to 5, 5.5. Then we'll have 10.5, 15.5. Very easy, right? Simple. Once you know what to do, it becomes a very simple task. Almost no thinking involved. Finally, 40.5. Right, so now our cumulative frequency curve will use this and this as our axes, right? However, we need to start our cumulative frequency curve from 0 at the horizontal axis, which is this axis here, right? Our cumulative frequency curve always needs to touch this axis. And before I go into how we're going to get that, let's actually draw our cumulative frequency curve first. Let's plot the points, okay? So our first point is going to be 5.5 and 4. Just so you know, let's label our axes. The vertical axis here is going to be our cumulative frequency. Right? Cumulative frequency. And it goes all the way to 80. So our scale should be probably 5 for each block, right? Let's see if that will work. Hopefully it will. Oop, I made a mistake. Excellent. So it fits, okay? And our horizontal axis is going to be our upper class boundaries, okay? But we can't label it upper class boundaries. We need to, this is actually the time that the student's waiting, right? So we're just going to label it waiting time, okay? In minutes, so minutes, okay? I'm going to put a 0 here. So the total amount of time that somebody would have been waiting was around 40.5, right? So I think we should just use 5 for each centimeter again. Okay, that should be it there. Right. So let's plot our points now. So our first point would be 5.5 and 4. Right, so let's see what we have here. So remember, we are not 5, right? The upper class boundary will be 5.5. So if we zoom all the way up here, it's going to be right around this mark here is our first point. Alright, 5.5. This would have been 6, 7, 8, 9, and 10. 5.5 is half that little box, right? And 4 is obviously easy. 1, 2, 3, 4. Our next point, 10.5. 11. What am I doing? Sorry, 1 second. 10.5 and 11. Is that right? Yes, 10.5 and 11. And in the same way, we're going to do 0.5 and 11 will be right here. Easy. Our next point will be 15.5 and 22. Let's see where we are. Here. All right, 15.5 and 22 will be here. Next, 20.5 and 40. 20.5, 40 will be right here. 25.5, 62. Okay, I'll zoom out a little bit so you can see what we're doing. 25.5 goes all the way up to 62 here. 30.5 and 72. That's right around here. 35.5, 77. And then finally 40.5, 80. So 40.5 would run us all the way up to here. Okay. So all we need to do now is draw a smooth curve through the dots. Okay, we don't need to connect the dots with straight lines, right? That's not what a curve is, right? That's more of a polygon, a shape, right? So our curve needs to be very smooth. However, our curve needs to start, it needs to start from the bottom. Okay, it needs to start from the horizontal axis at 0. Okay, so we need to kind of backtrack our curve. But where do we start the curve? Do we start it from here? Do we start it from here? Where can we start? And the easy thing to do is to look back at our data. Remember, the points that were being plotted on the horizontal axis were the upper class boundaries. If you notice, with all these upper class boundaries, they were going in 5s, right? 5.5, 10.5, 15.5. So what would be before 5.5? 0.5, right? So if we put a 0.5 before there, we could assume that no one got 0.5, right? Because it said the least 4 students got was 1 to 5. So the amount of students who got 0.5, like 0.5 minutes, is 0. No student got that. Okay, no student was so fast in the canteen, right? The minimum would have been 1 to 5, and only 4 students got that. So no student in this data got served within 0.5 minutes. So where does 0.5 minutes, where's 0.5 minutes here? All the way over here, right? This was 1, 2, 3, 4, 5. 0.5 minutes is there. So that's where we want to start. Okay, wherever we can get 0 students, or 0 any frequency to be 0, wherever that coincides with the time or whatever is on our horizontal axis, that's where we start our curve. So now that we know where we start, we could draw a point, we could put a point here. Now we can draw our curve. Now this is probably not going to look the best, but let's try. Okay, do ever stop your curve, right? And that is essentially the cumulative frequency curve. Okay, very simple. Once you know the points that you have to plot, which is your upper class boundary versus your cumulative frequency, that's your cumulative frequency curve. However, we would not have gotten full marks for this graph if we drew it correctly like this. Do you know why? We forgot to put in our scale, right? Whenever you are doing a graph, no matter what subject it is, somewhere on top here you need to write your scale. Okay, so our vertical axis, we said 1 centimeter represents 5 students, right? Our frequency was in students. Okay, the horizontal 1 centimeter represents 5 minutes. That's our scale. However, we still wouldn't get full marks because we forgot something else again. The title of the graph. It goes right over here on the graph. So it's a cumulative frequency curve. Alright, so cumulative frequency versus waiting time. Alright, you just need to put your axes in the title and you'll be fine. Okay, there we go. That's how we get full marks in our graph. So now we need to utilize our graph. Okay, they want us to find the median of the data. Okay, so remember, the median of the data will be half the number of students. Okay, so let's find that. Hopefully my graph is not totally out of whack. Now you're going to get a little bit of leeway in between, right? Some people graph might be a little bit more to this side, some people might be around that side, but once we get the general graph, no matter what answer you get, whether it will be 19, 20 or 21 for example, you're going to be fine. Okay, so the median half of the students that were in the class, 40. Here we have 40. So all we need to do is look across our graph to where 40 would be. 40 hits here. Now let's look down to what would be the waiting time of that 40th student. I got 21, right? So you see, we read off the graph very easily. 20, this is not 140, sorry, that was just a line. But so the 40th student would have waited 21 minutes according to our graph. So let's write 21 minutes. They want to find the number of students who waited no more than 29 minutes. No more than 29 minutes simply means who waited less than 29 minutes, okay? So let's look at our graph. The minutes are on the horizontal, right? So let's find 29 minutes. I'm going to change the color so you will not get confused. 29 minutes would be 25, 26, 7, 8, 9. So let's go up to meet our graph. Here we go. This is a lot of people. Right here. And now let's see how many students did not wait more. 70, exactly 70 students did not wait more than 29 minutes. Once all these students here on the graph here, they waited more than 29 minutes, right? Right, so we could write 70 students. Now finally, they want to know the probability that a student chosen at random waited no more than 17 minutes. So first we need to find how many students did not wait more than 17 minutes. Well, let's go back into our graph. I'm going to change the color again. Let's look for 17 minutes. 15, 16, 17. So let's go up. Let's see where we reach. I think 25 is a safe number to choose here. It's our graph at 25 people. So 25 students did not wait more than 17 minutes. So the total amount of students we had in the class was 80 students. So the probability is 25 over the 80 students. And we can round this down. We can go 5 into 25 is 5. And you can, if you're not sure about how much could go into 80, I know that 5 could go into 80 16 times, right? So it's 5 on 16. That's what I got. Some people might get 26 students instead of the 25, but as I said, there's a leeway between what answer you would get, right? And that's the probability, 5 on 16. So that's really the end of our past paper session. I hope you guys learned something. If you have any questions about these answers, you can feel free to WhatsApp me, okay? Thanks everyone.